morning and welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. Okay, we'll be solving some questions, and the first one said if alpha and beta are the roots of the equation 2x squared minus 3x minus 6 is equal to 0, find the equation whose roots are 1 over alpha and 1 over beta. Now, before you solve anything in roots of quadratic equation, you need your alpha, beta, and alpha plus beta. So solution, okay, we have that we have 2x squared minus 3x minus 6 is equal to 0. This implies that a is equal to, a is this, a is the coefficient of x squared, which is 2, b is equal to the coefficient of x, which is 3, okay, and the c is minus 3, and c is now the last constant term there, which is what? Minus 6, okay. So we need alpha plus beta, and alpha plus beta, the formula is minus b over a, which is what? Minus, before you now have minus 3 all over what? 2. So I'm having a what? 3 over 2 is alpha plus beta. So the next thing we need to get is what? Alpha beta. And alpha beta is simply what? C over a, which is what? Minus 6 over 2, which is equal to minus 3. Okay, if you have gotten this thing now to get the root of a quadratic equation, it has a formula. The formula said x squared. So if you want to find a quadratic equation, okay, if you want to find a quadratic equation, the formula is simply x squared minus sum. When I mean sum, I mean sum of the roots, okay. You now put x plus product of roots is equal to 0, okay. So please put this as sum of roots, okay. I just wrote sum, and this one what? Product of roots. So we need sum of roots, sum. So the sum of the root, they say we should find the equation whose roots are this and this. So we need the sum of these roots. So the sum of these roots will be 1 over alpha plus 1 over what? Beta, which is equal to what? LCM is what? Alpha beta. When alpha beta divide this, I'm having beta. Beta times 1, I'm having beta. Plus, when this divide by this, beta cancel beta, I'm having alpha. Alpha times 1, I'm having what? Alpha. If you arrange it very well, you have what? Alpha plus beta all over what? Alpha beta. So which is equal to what? Alpha plus beta gave us 3 over 2. 3 over 2 divided by, because over means divide. Divided by what? Minus 3. So if I change divide to times, I'm going to have 3 over 2 times 1 over minus 3. Okay? Because in changing division to times, they will swap. So 3 will cancel 3. I'm having what? Minus. I'm having minus 1 over 2. So this is the sum. Now the next thing we need is the product. And the product is simply to multiply both of them, which is what? 1 over alpha times 1 over beta. And my answer is what? 1 over alpha beta, which is equal to what? 1 over alpha beta is what? Minus 3. Okay, which is equal to what? Minus 1 over 3. So this is my sum of roots and product of roots. So permit me to continue here. Okay, so now to get the equation becomes now the formula said x squared minus the sum of roots. You now put what? X plus what? The product of roots, okay, is equal to 0. So what do we have now? X squared minus, now the sum of roots, we got it as a minus 1 over 2. You put your x plus the product, we got it as what? Minus 1 over 3 is equal to 0. Okay, now if you look at this, the LCM here is 6, but before that I'm having x squared plus x over 2, because 1 times x is x, plus is because minus is plus. Okay, minus plus minus is what? Minus. I'm having 1 over 3 is equal to what? 0. Now to clear the denominator, you multiply each of the terms by what? The LCM. Multiply each of the terms by the LCM. So, and the LCM here is what? 6. You say multiply each by what? By 6. So I'm having what? 6x squared plus 6 in bracket of x over 2 minus 6 in bracket of 1 over 3 is equal to 6 in bracket of 0. This time this 6x squared, this take care of this, I'm having 3. 3 times this plus 3x, this take care of this, I'm having 2. This time this minus 2 is equal to 0. So this is the required equation. So question number B said we should find 1 over alpha plus 1 over beta. We have gotten it here. Look at it. That's the sum. 1 over alpha plus 1 over beta. And we got the answer as what? Minus 1 over 2. Okay? So that is that. Now let's take the next question. This is question number 1. Now question number 2. Question number 2 says, so question number 2 says, find the value of k given that the roots of 6x squared plus qx plus 2 is equal to 0. Okay, are reciprocal. Okay, to each other. Now if you look at this question, you see that there is a mistake somewhere. The question is wrong. Okay, they say we should find the value of k, and there is no k in this equation, so the equation is wrong. Okay, the equation is wrong. But if we assume that here is k, you can't even still find it, because if you are talking about the when the roots are reciprocal to each other, let me show you. The only thing that can make us get k is maybe we have, in fact that k should be at what? At the end term. It can be what? 2k, or simply 2 plus k, or 2 minus k, anyone. But let me solve it using 2k. Remember, the question is wrong. I'm now the one solving it using what? 2k. If I want to solve it using 2k, we'll see that what? We know that solution, they gave me that what? 6x squared plus qx plus 2k is equal to 0, which means my a is equal to 6, my b is equal to q, my c is equal to what? 2k. Okay, now don't forget that what? Sum of roots alpha plus beta is equal to what? Minus b over what? A, which is what? Minus q over 6. And alpha beta is equal to c over a, which is equal to what? 2k over 6. Okay, now we know from here we know that alpha beta is equal to what? This cancel this, I'm having what? K over 3. Now they told us that what? That the roots are reciprocal to each other, which means if I have alpha, then beta must be equal to 1 over alpha, the reciprocal of the other one. Reciprocal means 1 over. So anywhere I see beta, I can put 1 over this. So it will now be what? Alpha times 1 over alpha is equal to what? K over 3. Now alpha cancel alpha, I'm having a what? 1 is equal to what? K over 3. Now if I cross multiply, therefore my k is equal to what? 3. Okay, if you cross multiply, k times 1 k, 3 times 1 3, so we have that k is equal to 3. That is if the question is what? 2k. Are you getting it now? Very very important, please. So that is that. Okay, but the question is wrong. So let's move to the next question. Question number Question number 3. Now, question number 3 said A and B, okay? A and B are subsets. Are subsets of a universal set. A universal set having 12 elements, full stop. If A has 7 elements, B has 7 elements as well, okay, full stop. Okay, and A intersection B has 9 elements. Has 9 elements. Okay, full stop. Then I say find the number of elements. Find the number of elements in A union B. Okay. Now it's very simple. I'm going to solve this thing in two ways. I'm going to solve it using Venn diagram and solving it using normal set theorems. Okay. Now using set theorems, I know that A union B, okay, the number of A union B is equal to what? The number of A plus the number of B, okay, minus the number of what? A intersection B. A intersection B. Okay, you need to know this formula. That the number of A union B is equal to what? Number of A plus number of B minus number of A intersection B. So number of A is 7 plus another 7 minus what? 9. So I'm having 14 minus 9, which will give me 5. Okay, so we got this as 5. So let us solve it with Venn diagram alternatively. Alternatively, if we want to use Venn diagram, okay, we have that this is my A and this is my B. Okay, why I do it like this? Because they have intersect, and I told you when you are doing a Venn diagram of two sets, you can go and watch my video on Venn diagram, that you will start from the intersection of two of them before you go to 1 So intersection of two of them is 9. They have 9 elements, so I'm having 9 here. Okay, and then I say let's go to 1 in they say that A has 7 elements. A has 7 elements. They did not say only. Had it been they said only, I'll just write the 7 here. But because they did not say only, I will say 7 minus that 9. You see, I did not use 9 because 9 is the bigger one. Is A first minus their intersection. So with what I'm having here is what? 7 minus this will give you minus 2. Now, they equally say that B has 7 elements. So to get B only is what? That 7 elements minus 9, which is equal to what? Minus 2. Okay, so what else are they saying? Then I say we should find the number of, we are finding the number of what? A union B. Now for you to find the number of A union B means unite everything in the circle of A and B together, which is what? Minus 2 plus 9 plus minus 2. Okay, which will give you minus 2 plus 9 minus 2, which will give you what? 5. The same answer here. Okay, you see that? The same answer. So let's move to the next question. Please, you can watch my video on set for you to understand more. So the next question said, question number 4. Question number 4 said, given that A is equal to the set of 1, 3, and 4, and B is equal to a set of X, which is an element of a real number, such that X squared minus 7X plus 12 is equal to 0. Okay, then I say find I question A symmetric B. This thing means symmetric. I question power of A union B. Power of A union B. Okay, solution. Let's get their element. Normal element of A is given as 1, 3, and 4, but element of B is given as what? Let us get it. You need to solve this thing simultaneously for you to get the element of A and B. So let me get that. I have X squared minus 7X plus 12 is equal to 0. Now, how do you remember how to solve factorization method of quadratic equation? This is a quadratic equation, so let's solve that. I'm having X squared minus 3X minus 4X plus 12 is equal to 0. If you don't understand it, go and watch my video on quadratic equation. So I have this. The common term here is what? X. This divided by this, I'm having X minus 3. Anything that is here must be here. X minus 3. How do you get the person outside? Minus plus minus. 12 divided by this, 4 is equal to 0. So what do we have now? What is common between this line and this line is X minus 3, and the remaining term is now what? X minus 4, okay, is equal to 0. So what do you say now? You now say that x minus 3 is 0 or x minus 4 is 0. So what do we have now? X is equal to what? 3 or x is equal to what? 4. So the elements of this are what? 3 and 4. Okay, so it will now help us to answer the questions. So answering the questions now, I now have the first one said A symmetric B, and A symmetric B means what? The union minus the intersection, which is what? A union B, okay, minus A intersection B, okay. So and A union B means what they have unite them. If I unite them, I'm going to have 1, 3, and 4, okay, minus their intersection is what they have in common, and what they have in common is what? 3 and 4. So if you minus 3 and 4 from here, the only thing that is remaining is what? 1, okay. Alternatively, A symmetric B simply means what they don't have in common, and if you look at these two things, what they don't have in common is simply 1. So 1 is the what? The symmetric, okay. So any way you like to solve it. If it's an objective, use this method, but if it's theory, use this method, okay. So I said the power of A union B. Now we have gotten A union B to be what? 1, 3, 4, okay, which means and power of a set is what? The formula is 2 raised to power n, where n is what? The number of that element you are talking about, and the number of elements in A union B is 1, 2, 3. They have just 3 elements, so which means the power of A union B is simply what? 2 raised to power that 3, which is what? 8. That is 2 times 2 times 2, okay. So we are done with question number 4. So let's move straight to question number 5. Question number 5. Okay, question number 5. Question number 5 said that we should solve the simultaneous equation. They gave us 3 raised to power x plus y is equal to 3 raised to power 5, and 2 raised to power 2x minus 5y, okay, is equal to 8. As simple as that. Solution, very simple. Now they gave us that 3 raised to power x plus y is equal to 3 raised to power 5. Now 3 will take care of 3, therefore x plus y is equal to 5, equation 1, okay. From here they gave me 2 raised to power 2x minus 5y is equal to what? 8, which is 2 raised to power 2x minus 5y is equal to, reducing 8, I'll have 2 raised to power 3. Now 2 will take care of 2, therefore 2x minus 5y is equal to 3, equation 2. Now we need to solve this equation 1 and 2 simultaneously, okay. So I have solution, solving it simultaneously. You need to multiply these people by the coefficient here, which is 2, and multiply these people with the coefficient here 1. So 2 times this 2x, 2 times this 2y, 2 times this 10, 1 times everything is the same thing. 2x minus 5y is equal to 3. So let us subtract. We are using elimination method. They are now equal. We can eliminate this minus this, 0. Minus minus is plus. 2 plus 5 is 7y is equal to what? 10 minus 3 is what? 7. Therefore y is equal to what? 7 over 7, which is equal to what? 1. I have gotten y to be 1. So to get x is substitute in equation 1 or equation 2. So we tell them substitute y to be 1 in equation 1. And equation 1 said that x plus y is equal to 5. Therefore x plus 1 is equal to 5. X is equal to what? 5 minus 1. So x is equal to what? 4. So therefore x is 4 and y is 1. As simple as that, okay. I'm still going to drop a video on simultaneous equation, okay. So that is that. The next one, number 6. Number 6 said number 6 said find the remainder when f of x, which is equal to x raised to power 4 minus 3x raised to power 3, okay, minus 10x squared plus 2x minus 10 is equal to 0. Okay, is divided by x minus 3. Okay, now we are going to use what is called the remainder theorem solution. The remainder theorem said if a polynomial is being divided by another linear polynomial, okay, that the remainder is simply substitute x to be the constant here. So just do x, just say x minus 3 is equal to 0 to imply that what x is equal to this one, move your what 3. So the remainder is simply f of that 3, which is equal to what? Anywhere you see x, put 3, which is what? 3 raised to power 4 minus 3 into 3 raised to power 3 minus 10 into 3 raised to power 2 plus what? 2 into 3, then what? Minus 10. Okay, let's get the answer. So I'm having 81 here minus 81 here, because 3 raised to power this is 27. 27 times 3, 81 minus 90. 3 raised to power 2 is 9. 9 times 10, 90 plus 6 minus 10. Okay, so I'm having this 2 is gone. Minus 100 plus this will give you minus 94. That is the remainder. The remainder is simply minus 94. Okay, so let us solve the next one. Number 7. Number 7 said, using the principle of mathematical induction, using the what? The principle of mathematical induction. Okay, using the principle of mathematical induction, comma, prove that a question that 1 raised to power 2 plus 2 raised to power 2 plus 3 raised to power 2 plus ... plus any raised to power 2 is equal to 1 over 6 n bracket n plus 1 bracket 2n plus 1. Okay, then B question said that 1 times 2 times 3, 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus n into n plus 1, okay, is equal to n bracket n plus 1 bracket n plus 2, everything over 3. Okay, now to solve this thing is very, very simple. You can watch my video on principles of mathematical induction, okay, but let us solve this. Now, in principles of mathematical induction, we need 5 things. The first one is that you assume that Sn statement is true. So the first one is what? Assume that Sn statement is true, and it simply means to write down the equation. That's all. Sn is equal to 1 squared plus 2 squared plus 3 squared plus ... plus n squared is equal to 1 over 6 n into n plus 1 into 2n plus 1. I'm done with this. The next one is to prove. Number 2. The next thing to do is what? To prove that S1 statement is true. Now it means S1, anywhere you see n, put 1. S1, I have 1 squared plus 2 squared plus 3 squared plus ... plus 1 squared is equal to 1 over 6 into 1 into 1 plus 1 into 2 into 1 plus 1. Okay, so I'm having that 1 is equal to 1 over 6 bracket 1 bracket 2 bracket 3. Okay, now once you get that 1 is equal to 1, then you are correct. So therefore S1 is equal to 1 squared plus 2 squared plus 3 squared plus ... plus 1 squared is equal to 1 over 6 bracket 6. You see, if you multiply this 1 times this times this, so 6. I'm having that what? 1 is equal to 1. Once you have gotten that 1 is equal to 1, you will continue. But if you don't get that they are equal to, like maybe you got 7 here is equal to 6, don't continue. It doesn't work. Okay, you stop there. But if you get that the left hand side is equal to right hand side, after putting 1, then you continue. And the next thing you do is to do what? To assume again. Assume that SK statement is true. Statement is true. Let me continue from here, please. That place, the space is not okay. Okay, after this one, the next thing you do is what? To assume that SK statement is true. Assume SK statement is true. Okay, it simply means SK equals anywhere you see any again, put what? K. So I'm having 1 square plus 2 square plus 3 square plus ... plus K squared is equal to 1 over 6 bracket K plus 1 bracket 2K plus 1. You are done here. The next thing you are doing is to assume SK plus 1 statement is true. Assume SK plus 1 statement is true. Okay, so what does it mean? That anywhere you see SK, put SK plus 1. Okay, anywhere you see K now, put K plus 1. Or anywhere you see N, just put K plus 1. So I'm having that this is equal to 1 square plus 2 square plus 3 square plus ... plus here I'll put what? K plus 1 all square is equal to 1 over 6 into K plus 1 into K plus 1 plus 1 K plus 1 plus 1, okay, into, okay, 2 into K plus 1 before plus 1. Okay, so what I'm having here is what? 1 over 6 into K plus 1 into what? K plus 2 into 2 times this 2K, 2 times this 2 plus this one 3, 2K plus 3. Okay, so now the last thing you are going to do is now to prove that SK implies SK plus 1. So the last thing to do is what? To prove that SK implies SK plus 1. So that's the last thing you're going to prove. Okay, all right, let us do that. Prove that SK implies SK plus 1. What do you do in this case? Simply do, if you come to that SK, because I started with SK, okay, carry anything in the left hand side of SK plus 1 and add to the both side of SK. Carry anything in the left hand side of what? SK plus 1, add to the both side of SK. So I'm going to have that what? My SK, permit me to clean here. Let me write down this question first. Okay, maybe I'll get the question for number 2. So let us go. So I'm having that, and our aim is that we want to get this thing after doing what we are doing. Okay, we want to get this. So let us add. I have that my SK is equal to 1 square plus 2 square plus 3 square plus ... plus K squared plus, let me add now. I'm adding K plus 1 squared to the left hand side. So let me add to the other side. Sorry. 1 over 6 bracket K plus 1 bracket 2K plus 1. Okay, plus, okay, plus you are adding, what am I adding? K plus 1 all square. Okay, now if you let us factorize, first of all you bring out 1 over 6. Okay, if you bring out 1 over 6, okay, if you bring out 1 over 6, which means you are multiplying everybody by 6. Okay, you are multiplying everybody by 6. That is what we cancel out. Or you do LCM. In fact, let me do LCM. That is what you understand. I hope you know that this thing means K bracket K plus 1 bracket 2K plus 1 everybody over 6 plus K plus 1 into another K plus 1 everybody over 6. So the LCM now is what? 6. I hope you are seeing it. 6 divided by this. Sorry, over 1, not over 6. Sorry, over 1. Okay, 6 divided by this 1. 1 times this, I'm having K bracket K plus 1 bracket 2K plus 1 plus 6 divided by 1, 6. 6 times this, I'm having 6 into K plus 1 into K plus 1. So now I'm going to have that this is equal to, now let us factorize. All of them has 1 over 6 in common. So I brought out that 1 over 6. all of them have k plus 1 in common. I brought out k plus 1. So what is remaining in this side is what? Simply k in bracket of 2k plus 1. That is remaining here. Plus, what is remaining here is what? 6 with 1 of the k plus 1. Okay? Because I brought one of them out. So it's meaning what? This and this. So now let me clear this one inside here. I'm having what? 1 over 6 bracket k plus 1 bracket. Now, this time this will give you 2k squared. This time this will give you plus k. This time this will give you what? Plus 6k. This time this will give you what? Plus 6. Okay? So let me write this thing out because this is what we are intended to get. We are intended to get 1 over 6 into k plus 1 into k plus 2 into 2k plus 3. So let us continue. So we now have that this is equal to 1 over 6 bracket k plus 1 bracket 2k squared plus 7k plus 6. Are you with me? Now if you factorize this thing, let us factorize this. If you factorize this one, I'm having 2k squared plus 7k plus 6. So I'm having that 2k squared. This time this is giving me 12. So I'm having plus 3k plus 4k plus 6. So what is common is 2k. What is common here is k. I'm having k plus 3. What is common here is k. So I'm having here 2k plus 3. And the same 2k plus 3 will be here. So plus plus is plus. This divided by this is 2. So I'm having 2k plus 3 and k plus 2. Okay? So when you factorize this thing now, it's going to give me 1 over 6 bracket k plus 1 bracket. When I factorize this thing, I got k plus 2 and 2k plus 3. You see, we got the same thing as this. You see, since we got the same thing as the right hand side of k plus 1, I told you, carry the left hand side of k plus 1, add it to the both hand side of what? Of k to get the right hand side of k plus 1. Let me repeat, that's even the main thing. Once that you prove that S1 is true, the next thing that you need to prove is that what? Carry the left hand side of k plus 1, add it to the both side of what? SK. Then solve the right hand side of SK to get that right hand side of k plus 1. You are done. So since we have gotten it, we have done. We now say therefore, okay, therefore, for all n, please write the statement too. Therefore, let me see. Okay, let me write the statement. So we are done with this. We now say therefore, the question, therefore 1 squared, therefore Sn, which is equal to 1 squared plus 2 squared plus 3 squared plus plus n squared is equal to 1 over 6 n into n plus 1 into 2n plus 1, okay, holds for all n being an element of what? A real number. Is that what they gave us? Being an element of a real number, okay? Or you just say that, you just, after this thing, just write proved. If you don't want to write this statement, it's the same thing. Okay, just write proved. So the next question, let's solve that P1. The P said 1 times 2 plus 2 times 3 plus 3 times 4 plus plus n into n plus 1 is equal to what? Is equal to n into n plus 1 into n plus 2 all over 3. Okay? Now the first thing you say what? Assume that Sn statement is true. You just say Sn is equal to, you write your question. You are done with that. The next one to do is what? To prove. You prove that S1 statement is true. So let us prove it, which means S1 is equal to 1 times 2 plus 2 times 3 plus 3 times 4 plus plus 1 bracket 1 plus 1 is equal to 1 bracket 1 plus 1 bracket 1 plus 2, everything over 3. Now, in fact, this plus this, 2 times 1, 2 is equal to, now, this plus this 2, this plus this 3. So 3 can cancel 3. I'm having that 2 is equal to 2. So since the left hand side and the right hand side are equal, okay, you continue. And the continuation is to assume SK. Assume SK statement is true, okay, which means SK is equal to, anywhere you see n, put K. I'm having 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus K into K plus 1 is equal to K bracket K plus 1 bracket K plus 2, okay, everything over what? 3. Are you with me? So we are done with this. So the next thing to do is what? To assume SK plus 1 statement is true. Assume SK plus 1 statement is true. Okay, what does it mean? Anywhere you see n now, put K plus 1, or anywhere you see K, put K plus 1. So I'm having SK plus 1 is equal to 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus K plus 1 first. I've seen it here in bracket of K plus 1, then before plus 1 is equal to K plus 1 into K plus 1 plus 1 into K plus 1 plus 2, okay, all over 3. So what I'm having here is what? K plus 1 and K plus 2 is equal to K plus 1, K plus 2, and K plus 3, and K plus 3, all over what? 3, okay? Now, the last thing to do is now to prove that SK implies SK plus 1. Prove that SK implies SK plus 1. So what do? Carry the left hand side of SK. Carry the left hand side of SK plus 1, sorry, and add to the both side of SK. So I'm having SK is equal to what? 1 times 2 plus 2 times 3 plus 3 times 4 plus ... plus K into K plus 1 plus carry the left hand side of SK plus 1, which is what? K plus 1 into K plus 1, okay? Sorry, into K plus 2. And add it to both sides. So I've added to this side. I need to add to the other side. Is equal to K bracket K plus 1 bracket K plus 2 all over 3 plus, I'm adding the same thing again, K plus 1 and K plus 2. Okay. Hi there. So we'll now start solving this right hand side to know if we will get the right hand side of K plus 1. That's all. You are done. So let's continue. So this is equal to, I'm solving here. So I'm having that what? The LCM they have is what? 3. So 3 divided by this 1. 1 times this is what? K bracket K plus 1 bracket K plus 2. Okay. Plus, for this is over 1. This divided by this 3. 3 times this. 3 bracket K plus 1 bracket K plus 2. Are you with me? So now, if you look at this, they have 1 over 3 in common. If I bring out that 1 over 3, what else do they have in common? They have K plus 1 in common. K plus 1 in common. What else do they have in common? K plus 2. They have K plus 2 in common. So what is now the remaining? K and plus 3 is remaining. K and plus 3 is remaining. So if you look at this thing is the same thing as saying K plus 1 into K plus 2 into K plus 3 all over again in 3. And this is the same thing as this. Okay? Since you have gotten that the same thing, you now write proved. Proved. Okay? As simple as that. So let's go to the next question. See, mathematical induction is very simple. Okay, so the next question said, question number Question number 8. Question number 8 said, determine how many ways 8 Indians, comma, 4 Americans, comma, and 4 English. 4 Englishmen, okay, can be seated in a row so that all persons of the same nationality sit together. Now, solution. Now let me represent Indians with I. So I have how many I's? 8. 1, 2, 3, 4, 5, 6, 7, 8. These are for Indians sitting here. Americans represent with A. American, 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 American. 8. Okay? English, E. E. Now, in how many ways can these people sit the way they are? It is how many are they? 1, 2, 3, 4, 5, 6, 7, 8. It's just 8 factorial. Times. In how many ways can these people sit? 4 factorial. In how many ways can these people sit? 4 factorial. Now, in how many ways can 1, 2, 3 people sit? 3 factorial. Okay? So, in how many ways can they sit? They can sit in this. 3 factorial, sorry. So, this is your answer. Okay? As simple as that. They can sit in what? These 10 ways. If you want to get the normal answer, do that. 8 factorial means 8 times 7 times 6 times 5 times 3 times 4 times 2 times 4. In fact, the real answer will not be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for this 8 factorial times 4 factorial. 4 times 3 times 2 times 1 times 4 factorial again. 4 times 3 times 2 times 1 times 3 times 2 times 1 ways. Okay? Get the answer and write ways. As simple as that. Number 9. Number 9 said, okay, how many different words, how many different words can be formed, okay, can be formed using all the letters of the word COSMOS, cosmos. When letter S, okay, when both X, okay, do not occur together. Okay, solution. Now, without any condition, okay, the number of words that can be gotten from here without any restriction. First of all, no restriction. No restriction is simply how many are they? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6 factorial all over. C is how many? 1. Leave it. Anyone that is from 2 and above, write it. O is how many? 2. 2 factorial at the denominator. S is how many? 2. 2 factorial again at the denominator. M is 1, so leave it. So my answer becomes what? 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times another 2 times 1. So 2 take care of 2 and 2 take care of 4 to have 2. So what do I have now? 6 times 3, 18. 5 times 2, 10. That is 180. 180, okay? 180 words. Or 180 words without restriction. Now we cannot get when they are separated. but we can get when they are together. So if we have cosmos like this, cos being together like this, okay? So the number of ways when they are together, if s are together, it will now be equal to, now being together means they are now 1. So I'm having 1, 2, 3, 4, 5. That is 5 factorial all over. Is there anyone that is 2? Only C is 2 because these people are now together. So I'm having 2 factorial. So what do you have? 5 times 4 times 3 times 2 times 1 all over 2 times 1. So 2 take care of 2. So I'm having 4 times 5, 20. 20 times 3 is 60 words. So when they are not together, if s are not together, okay, it's simply without restriction, which is 180 minus when they are together. So which is what? 120 words. Okay, as simple as that. 120 words. So the 10th question. Question number 10. Question number 10. Now question number 10 said find the constant term. Let me check my time. Okay, find the constant term. Find the constant term in the expansion of bracket x plus 1 over x all raised to power 10. Solution. I know that a plus b all raised to power n, the expansion is n combination. In fact, sorry, the expansion is the summation of what? R starting from 0 to n, okay, of n combination r, a raised to power n minus r, b raised to power r. Very important formula. Okay, now let us compare this and this. It means that my a is x and my b is 1 over x and my n is what? 10. But I don't know where my r is. I don't know what is my r. To get the particular one they are telling me, the particular constant term. Okay, so but let us substitute in this formula. I'm having the what? 10 from here. Let us substitute here. I'm having a 10 combination r. I don't know my r, in bracket of x raised to power 10 minus r, because my a is x. Okay, then my b is what? 1 over x all raised to power r. Okay, so this is what? 10 combination r, then x raised to power 10 minus r, then times x raised to power minus r, or okay, let me say times 1 over x raised to power r. Okay, so which is something as, let me continue here, 10 combination r, x raised to power 10 minus r. Okay, now if you want to remove 1 over in indices, the power will now be minus, so it will now be what? Times x raised to power minus r. So this is what? 10 combination r. Indices said if the base are the same thing, add the power. So I'm having 10 minus r plus minus r. Okay, now if they're asking you the constant term, it means that what? Pick the x, which is what? X raised to power 10 minus r is equal to x raised to power 0, because that is the constant term. If they say the constant term, you use x raised to power 0, or the term that does not contain x, you still use x raised to power 0. So if x cancel x, I'm having a what? 10 minus r is equal to 0. So which is 10 minus 2r is equal to 0. So therefore 10 is equal to 2r, and r is equal to 10 divided by 2, which is what? 5. Immediately you have gotten your 5, come back and put it in that equation. Where is that equation? Any of this equation, maybe put it here. Okay, so therefore the term that does not, the constant term is 10 combination 5. Okay, x raised to power 10 minus 5 plus minus 5. Okay, and everything here is giving me 0, which is what? 10 combination. In fact, 10 combination 5 means what? 10 factorial all over 5 factorial, then 10 minus 5 factorial. And here is what? 0. And anything raised by 0 is what? 1. That is why we call it the constant term. It does not have what? That x. So I'm having here what? 10 times 9 times 8 times 7 times 6 times 5 factorial all over 5 times 4 times 3 times 2 times 1 for this one. And this minus this is 5. 5 factorial again. So I have times what? 5 factorial. So 5 factorial will cancel 5 factorial. So I'm having 5 divide here. 2. Okay. 2 times 4, 8. It will cancel this 8. And 3 will cancel here to become 3. So I am left with 2 times 3 times 7 times 6. Okay. So which is what? So I'm left with 2 times 3 times 7 times 6. Okay, that is 252. 252. Okay, so the constant term is what? 252. Now the last but not the least question. The last question. Okay, in this last question, I'm going to read it out, or let me just write it. This question said, of the 200 candidates, who were interviewed for a position, at a cell center, 100 had a two-wheeler, 70 had a credit card, and 140 had 140 a mobile 140 a mobile phone, 140 a mobile phone. 40 of them had both a two-wheeler and 40 of them have both a two-wheeler and a credit card. Okay, 30 had both a credit card, and 30 had both a credit card and a mobile phone. Okay, 60 had both a two-wheeler and a mobile phone. Okay, I said 60 had both a two-wheeler and a mobile phone, and the 10 had all the three. Full stop. Then I say how many? That's a how many candidates had none of the three. Okay, solution. Okay, this is very simple. What do we do? This is a Venn diagram of 3. So let us draw. Now, I have the first one. The first one is two-wheeler, T. The second one is credit card, C. And the last one is mobile phone, P. Okay? Now, I told you that if you have a Venn diagram of 3, you must start from where they did the 3 of them. And they said 10 had all the 3. I will write 10 in the middle here. Okay? Now, let's move to 2, 2. They said 2, 2. 60 had both a two-wheeler and a mobile phone. Two-wheeler and mobile phone, 60 here. But they did not say only. Had it been they said only, I would just write 60. But because they did not say only, I will say 60 minus that 10, which will give you what? 50. So here is 50. Okay? Then the next one, 30 had both credit card and mobile phone. Credit card and mobile phone. Let me change this into M, mobile phone. Okay? Credit card and mobile phone is 30. Credit card and mobile phone 30. And they did not put only. So I must say 30 minus 10, which is what? 20. So the next one they will tell us is what? 40. 40 of them had both two-wheeler and credit card. So two-wheeler and credit card 40. And they did not say only. I must say what? 40 minus 10, because they did not say only, which is 30. Now, let's go to 1, 1. 1, 1. 140, a mobile phone. I'm supposed to write 140 here, but because they did not say only, I will say 140 minus everything that entered inside of mobile phone. 50 entered minus 50 minus 20 entered minus 20 minus 10 entered minus 10, which is equal to what? So I have 140 minus 50 minus 20 minus 10. So I'm having 60. So here is 60. So only mobile phone is 60. So let's go to the next one. 70 had credit card, and I did not see only. So I must say 70 minus everything that entered inside of credit card. So 70 minus 30 minus 10 minus 20. So what do we have now? 30, 40, 60. So 70 minus 60 is what? 10. So let's talk about they say 100 had two-wheeler. 100. So I'm going to have 100 minus everything that entered, because they did not say only. So 100 minus 40 minus 50 minus 10. So only this is even 0. So nobody did only two-wheeler. Okay? And then I say, how many had none? Let's say, let it be X. So you tell them, let the number of candidates, okay, that had none be X. You put it outside the circle, but it must be in the box of the universal set. Okay? So what do we have now? Now, add everything inside the universal set and equate it to the 200 they gave you. You are done. Set is the simplest thing you can do. So I'm having, now please, start from 1, 1, 1, 2, 2, 2, and 3, so you don't make mistakes. So I'm starting with 0 plus 10 plus 60 plus 50 plus 30 plus 20 plus 10 plus the X that is outside. Everything in the universal set. Add it to what? Equate it to what? 200, which is the general number of the candidate. So if you add everything here, I'm going to have 60 plus 50 plus 30 plus 20 plus 10, which is 170. So I'm having 170 plus X is equal to 200. So therefore, X is equal to what? 200 minus 170, which is equal to what? 30. Okay? So we have 30 candidates did not come with any of these three. So thank you very much for watching. Please don't copy. Master this thing, because you may see them in exam. May the peace of the Lord be with you. Please subscribe and share it to anyone that needs it. God bless you.